Hi guys, welcome to my channel. Today I am going to solve this problem GFG POTD minimum cost path. So it is marked hard, and again the code is looking very complex, but it will be very easy if you all know the approach how to solve this problem. So let's read the problem and try to approach it. So given a square grid which contains integer cost, we have to find the path from top left to bottom right cell. And we have to find that what is the minimum cost to reach from top left to bottom right. So let's see, 4,4 and 3,7. So one thing to notice here is whenever we are told to find the shortest distance from source to any destination, then we'll be applying Dijkstra's. Or source to any destination or source to all vertices in case of nodes. Then also we'll be applying Dijkstra's. So let's see how we can solve this, how Dijkstra's is working and how we can solve this. Okay, so for solving Dijkstra's, we'll be using 2-3 things. Like this is the priority queue. Priority queue, which is also known as min heap. Then we'll be using one result vector to store our answer, like to reach at particular index what is the minimum distance we required. 0, 1, 0, 1. This is result vector. Now let's iterate. Initially what we are going to do is this, the source is this and we have to reach here. So what is the minimum distance to like reach this index 1,1? So initially we will be pushing 4 to our this and 0, 0. The priority queue type will be like that I'll be explaining while I'll be doing the code, but this is the distance. Okay, so let me write this and this. So this will be the distance. Why I have stored distance in the first? Because when we push the elements in the priority queue, the first one will be the distance. Why? Because min heap will sort all the elements inside the priority queue on the basis of first element, and we want the shorter distance to be coming on the top, because whenever we'll be like popping the elements from the top, so we should get the shorter distance, and that we are going to explore first. So that's why I have kept distance first, and this will be I, this will be, this is I, this will be J. So what this like element in the priority queue depicts is to reach at index I comma j in the grid, this is the minimum distance we required. So this is what it like explaining. So to reach 0, 0 index, we need 4 distance. So here we can see that to reach 0, 0, here is the 4 distance. Now let's pop the elements one by one and start iterating. Initially all the elements, all the like index in result is infinity. Okay, so let's iterate. Now x is equals to 0, y is equals to 0, and distance till now is 4. So from 0, 0, where all index we can reach, we can go to this index, we can go to this index. Now we can go to 0, 1. And what is the new distance? New distance is previous distance, this. previous distance plus current index distance. So it will be previous distance is 4 and what is current like index distance 0, 1. What is in 0, 1? It is also 4. So we'll be writing 4 plus 4, which is equal to 8. Now we can go to next, we can go to okay, 0, 1, we can go to 1, 0. What is the like new distance? New distance here is, what is the previous distance? Previous distance is 4, means till 0, 0 we need 4 distance, and to reach from 0, 0 to 1, 0 we have to add what is present in 1, 0. 1, 0 it is 3 plus 4 previous distance, so it will be 4 plus 3, which is 7. Now to reach 0, 1 we got a less distance like 8. We have to check whether 8 is less than what is present in this 0, 1. Yes, it is infinity, but we got less distance, so we will be updating. So we will remove this, we will update it as 8, and we will push 8 comma what is the like index which require 8 to reach that index. So it is 0, 1. Okay, now let's come to 7. So to reach 1, 0 we need a distance of 7. So let's see in the result vector, like what is the like distance present in the index 1, 0. It is 7 and here it is infinity, so we got a less distance. So we'll be updating this, remove this and put 7. By the way, initially we are initializing 0, 0 as 4 because to reach 0, 0 we need 4 distance. Okay, so we have explored and we will also be pushing 7, 1, 0. Okay, now let's remove this and again pop one element from the top. So it doesn't matter that we have explored the 8, then we have explored 7. It doesn't matter if we would have explored 7 first, then 8 first, and pushed 7 and then 8, but this priority queue will push 7 at the first because this is minimum, this distance is minimum, so no need to worry about that. So now we will be popping the 7 and x will be 1, y will be 0, and to reach at index 1, 0 the minimum distance we required is 7. So distance is 7. Now from 1, 0 where all we can reach, let's remove. We are standing at this position, sorry, we are not standing at this, we are standing at this 1, 0. Now from 1, 0 we can reach to 0, 0, and we can reach to 1, 1. Okay, so to reach 0, 0 what is the new distance? So to reach 0, 0 previous distance is 7 and 0, 0 distance is, what is the distance at 0, 0, which is 4. So 7 plus 4, which is 11. Now we will check in the result vector whether to reach 0, 0 whether 11 is the shortest distance to reach 0, 0. No, it's already 4 because to reach 0, 0 we need only 4 distance. Why we will go here, then we will be coming here. So 4 plus 7, 4 plus 3, 7, then coming to 7 plus 4 is 11. There is no need of repetition, so we will not be updating this because 11 is greater than what we have stored in the result vector. Now we will be coming to 1, 1. To reach 1, 1, what is the previous distance? Previously we need 7 to reach 1, 0. Now the new distance will be 7 plus what is present in 1, 1. It is 7. Okay, so 7 plus 7 is 14. Now we will be checking in our result vector. It is infinity, but 14 is less, so we will be pushing 14 in our answer, and we will be updating like 1, 4, 14, 1, 1. Okay, this I should remove this. I should remove this. Now we have updated our answer. Now we will be exploring another path. Okay, so we will be now, what priority queue will do, it will take this element and it will push it down and push this to up. Why? Because this distance is lower, like 8 is lower. So now let's pop this element 0 comma 1. X is 0, y is 1, and distance is 8. Now from 0 comma 1, where all we can reach? From 0 comma 1, where all we can reach? We can go to 0 comma 0, we can go to 1 comma 1. By the way, if we are standing at particular index, we can go up, we can go left, we can go right, and we can go down. Four direction we can move. So from 0 comma 1 we can move to 0 comma 0, and we can move to 1 comma 1. Now to move to 0 comma 0, what is the minimum distance? So what is the previous distance to reach 0 comma 1 is 8, and what is the new distance is 0 comma 0 is 4. 8 plus 4, it is 12. So 12, but to reach 0 comma 0 we already have 4, which is the minimum, so no need to update 12. How 12 is coming, let me explain. So first we have came to from 0 comma 0 to 1 comma 1, which is 4 plus 4 8. Then again from 1 comma 1 to 0 comma 0, which is 8 plus 4, it is 12. So why to do this and come to this? We can directly, if we are standing at 0 comma 0, we can directly stay here, it is 4. So this is how we are not going to, this is why we are not going to update 12. Now let's come to 1 comma 1. So to reach 0 comma 1, what is the minimum distance? Is 8. Now it is 8, 8. And what is the new distance to reach 1 comma 1? It is 7. Here we can see 7. So we'll be adding 8 plus 7, which is 15. Now we will be seeing that whether to reach 1 comma 1, we already got the minimum distance, which is 14, and we are getting the new distance as 15. So we will not be updating. How it is coming 15? We can go to here from 0 comma 0 to 1 comma 1, which is 4 plus 4 8, and then 8 plus 7, which is 15. So we are not updating 15 because we already got 14 from here, this distance. 4 comma 3 7, 7 plus 7 15. So we have not updated. Now we have explored this path, we haven't updated this, so we are not pushing any element in the priority queue, so we'll be removing this. Okay, so now we'll be exploring new path, which is this. So x is equals to 1, y is equals to 1, and distance is equals to 14. So from 1 comma 1, where all we can move? From 1 comma 1 we can move to this, we can move to this. So we can move to 0 comma 1, and we can move to 1 comma 0. Now let's see, to move to 0 comma 1, what is the new distances? What is the previous distance? Is 14, plus what is the new distance? 1 comma 1, what is present in 0 comma 1? It is 4. 0 comma 1, it is 4. So we will be adding 4. So 14 plus 4, 18. So is the new distance which we got 18 to reach 0 comma 1, it is less or not? So it is not less, because we already got 8 to reach 0 comma 1. How it is coming 18? We have, okay, let me remove. We have gone here 4 plus 3 7, then we got here 7 plus 7 14, then we go here 14 plus 4 18. Why to go this side, then this side, then this side? We already got this side, like this. 4 plus 4 8, so we have updated it minimum, so no need to update this. Now to reach 1 comma 0, what is the previous distance? Which is 14. And what is the new distance to reach 1 comma 0? We can see here 1 comma 0, it is 3. So we'll be adding 3, so it is 17. So, but we'll be checking it in our result vector whether 17 to reach 1 comma 0, which is already 7, which is already less than 17. So we will not be updating it, neither 18 neither 17. So finally our priority queue will become empty, and we can remove this. Now what we can see here is we got the result vector ready, means to start from the starting index, we got the all elements, like all the index, what is the minimum distance to reach from S to all the vertices. I have written two conditions. Okay, let me write it again. So for Dijkstra's algorithm, tells is source to destination and source to all vertices. Means we got the minimum distance to reach the from source to destination, and we also got the minimum distance to reach to every index, like to reach from 0, 0 to 1, 1, which is the minimum distance is 8. To reach from 0, 0 to 1, 0, the minimum distance is 7, and to reach from 0, 0 to 1, 1, the minimum distance is 14. So by this way we are going to solve this problem, and this is how Dijkstra's code is working. So I will suggest you to all to run this, like try run this on this test case, then you will be getting the clear idea. So let's see the code. So this is the neighbors like neighbor vector I have initialized, like this is okay. Let me take it to the okay. Okay, so let's see what I have done in the code. So I have initialized the neighbor vector here. To move to to move down we need 1, 0. To move up we need -1, 0. To move left we need 0, -1, and to move right we need 0, 1. Like to, so this I have initialized in the neighbor vector. I'll be using further. N is equals to grid dot size. Result vector with int max. Result vector with int max infinity stored initially. Now priority queue with P. Let's see what is P. This is P. Define P is equals to pair of int comma pair of int comma int. So int comma pair of int comma int. Now what is this? This is the distance. This is I. This is j. So this I have initialized. Okay. Now we have initially pushed grid dot 0, 0, 0, 0. What is grid 0, 0? Which is this 4. Like we have 4, 4, 3, 7. Grid of 0, 0, which is 4. Like we have initially pushed 4, bracket 0, 0. This one, and initially marked result vector as 4. So this step is we are doing result of 0, 0 is grid of 0, 0. Grid of 0, 0 is 4. We have initialized it as 4. Now while pq not empty, what we are doing? So distance is equals to pq dot top dot first. So this is and this. Okay, so distance will be pq dot top dot first element, and this is second element. Index is equals to, let me write. So int comma int this is this, and this is this. Okay, so this is the distance, but let's see, this is the first and this whole is the second. So distance is equals to pq dot top dot first. So pq dot top dot first, which is the distance. Okay, it's clear. Now index is equals to pq dot top dot second. Index is equals to this whole depicting the index depicts whole, this index. Now how to get x and y? Then index dot first will become x and index dot second will become this y. So this is how we are doing. Index dot first will become x, index dot second will become y. Okay, let me remove this. Now what we are doing here is, okay, so let me do. So and while taking out the top element, we will pop the element. If we do not put write this pq dot pop, then it will go to a infinite loop, because we are again taking out element, without doing the pop operation. Now we are applying a for loop in neighbor vector and taking out one, this one. This is 0, this is 1. So new index axis, because we are standing on x comma y, we are applying 0 comma 1. It will become x comma y plus 1. So x y, this is direction of 0, this is direction of 1. we are doing. So neighbor of 0 we have added to x, neighbor of 1 we have added to y. So x plus what is neighbor of 0, which is 1, and y plus which is what is neighbor of 1, it is 0. So our new distance is x plus 1 comma y, which is we are moving downward direction. Okay, so our new index we got from current position, what we are jumping it, like next position. So we'll check that whether next of x is greater than equal to 0 and less than n, and next of y is greater than equal to 0 and less than n. To check that, we are, let's say we are standing here, we can't able to like cross the boundary, so this is the boundary condition. And finally we are checking in the result vector that whatever the distance we get, like we have calculated x, y, this, and whatever the distance we get, or 15 whatever we get, should be less than like if the new distance is less than whatever present in the result vector, then we will be updating our result vector. So this is this step. So let me explain it again. So in the result vector, whatever answer is stored in the new position, it is greater than the current distance what we have calculated. Let's say in result vector it is present 8 and current distance we have calculated is like 7 and it is present 8, so we will be updating in the result vector. So what we have done is we have updated the result vector. If condition is true, then we have updated result vector and we will be pushing that element in the priority queue. And finally, what is the source? Like from here we have to reach here, so we'll be returning result n-1 comma n-1. So this is like how this whole code is running, and I have explained the code better. So thank you all. Let's run this code. Okay, so this code is running. So thank you for watching and having patience. So thank you all.